Hi, this is Owen Reno, and this is my Project 6 for week 6 over deformation and stretch in 3D bodies. Oop. So looking at an overview, this is the composite body on the right that I have. We're going to look through what the deformation map outcome is, my different 3D curves, and we're going to look at just one of the 3D curves, looking at the undeformed and deformed lengths. So this is my deformation map that I had defined. It is very similar to the velocity vector, which we will look at in the code at the end. But right here, we can see that I have the z vector applied plus just a deformation map u of z. And so we can see that in the code here, it is the exact same what I have written down, the z1, z2, z3. So this is looking at a clip of the pyramid. So Z1 is just the 1 minus Z over Z max times S, and then it's the same for the T, and then it's actually zeros and Z3. So, and that's for the deformation. And so if we look at the tensor gradient here, we can see that the first invariant for the whole composite body, because these are applied for each body, is the same thing. First invariant is 1. So we look over here at this first invariant plot that comes out in MATLAB. It is all light blue because this first invariant is constantly 1 throughout the entire body. And that is just confirmed with this hand calc here. Moving on, looking at the 3D curves that I have in the body. So there are several because this is a linear composite body. There's lots of lines to close these objects. And so I decided to look at curve 5 here. It is being stretched from the x1 min, x2 min locations at the pyramid and stretching until the apex. So if we go into some undeformed length calculations of this, I have the line parameterized here with a limit of 0 s to 1 expressed. And so doing a simple hand calculation of the integral for the undeformed length, we can see that it comes out to around 17.32, which is confirmed by the code. And I also confirmed this with Wolfram Alpha to make sure that we were getting the correct values. And then moving on, for the deformed curve, we can look at how we parameterize it with the deformation map. So because this deformation map includes that z vector at the beginning, I inputted from the previous parameterization of the curve the -10 plus 10s, -10 plus 10s, and 10s for the z1, z2, and z3 coordinates. And then also there's a z coordinate intermixed here. So this is also going to become 10s and 10s. And so with this parameterization of the deformed curve, we're going to be able to calculate this length by taking the tangent vectors of that x vector. So this dx ds shows the derivative, the partial derivatives of the s values in the previous parameterization. And so this is the final value that I came out to, final vector that I came out to that we're going to use for the deformed length, which is just the square root of these values squared. So I have this expressed here and doing this hand calculation and confirming with Wolfram Alpha, we got 22.92, which is also confirmed with the deformed length shown at the bottom, 22.92. So now that I've shown these hand calculations, I will just show the code here at the end. Scroll up to the top. And so this is the code that I have ran. You can take time to pause and look through it. But we can see that for my body.map and body.fmap, these are the same throughout the entire code. Just different variables are being defined based on the parameterization of the initial body. So that's something to look out for, but it runs the same. And we have the v of x at the end that is from the previous project. And so this is also part of the map. And so that is just not the z vector, but it's the u of x, the z plus u of x, that's what this is, or I guess it'd be phi of x, or phi of z. And so I will lastly just show the plot that came out that I have images of. We can see that this plot is bending in the x1 and x2 directions. And the curve that I looked at is this curve right here. And it looks the same. And if we go through the command window, we can confirm again that that undeformed and deformed length of curve 5 right here is correct. So you can take the time to look at that if you'd like. And so that's everything that I've got for this video. Thanks for watching.